Hello everyone, thank you for being here. And I present myself. I'm Omid. I'm a technical lead engineer at Solution Group in France, an online real estate platform, and we're part of a European Aviv group. And today we are having, basically my principal role is modernizing distributed systems and going toward real distributed systems, APIs, microservice, and principally I'm focused on event-driven design and serverless. For 4 years, since 4 years, I never did a server. I'm fully event-driven. So now you know me. Today we're going to have a look.
Sorry, the MC was sick, so this is why.
Oh, don't worry, don't worry.
Started, it's fine.
Hey, it's okay, don't worry.
A new MC will come. Enjoy your presentation.
Thank you, Mehdi. And sorry. And today we are having sustainability has two pillars: renewing the energy and improving the consumption. So I'm not able to renew the energy for you, but I can focus on how we can, in an event-driven architecture and serverless, basically, how we can improve the consumption. So talking about serverless, we talk about compute services, storage, and brokers, event, integration between the services, and the data flow, the event flow, everything that transiting between these components. So, but before jumping to the patterns, let's align the product stuff and the business stuff. This is so important. Asking yourself the question: we are not designing the APIs or the system or the serverless APIs or the traditional APIs for just technical desire. So we need to align business and technical stuff. So let's have some question: how we can organize that data? What are our data? And how we can use this broker? Why we are going over asynchronous systems? And how we are transferring the data, their events, that entities between our components or different APIs. And finally, when we talk about serverless, normally we talk about event-driven design, event-driven architecture. So how we can optimize our events and how we can optimize our compute at the end. Compute is your code. It's what you are doing. Your developer is designing that. And jumping onto data, when you're designing your system, any system, serverless or distributed or traditional, we think about data. There is rarely the system that can work without data. So the first question is, what's my type of data storage? In serverless world, we have serverless relational databases, or we have NoSQL databases, document databases, collection-based databases, and blob storage. Now, kind of buckets that you are pushing the JSON object or CSV object or any kind of objects into that bucket. So the question here has, your database decision must be aligned with your needs. We just thinking about your needs. We are. Oh, sorry. It's a Friday at the morning, Everyone, we're waking up. Sorry, I'm a bit lost. So, choosing the right database is a crucial part of software. And the software is per needs. There is no software which is done for pleasure, And when we talk about the data, we are basically databases. We're basically talk about crude operations. Create, read, update, delete, and the most ugly part of this story is querying. Querying. We are fetching data from our databases based on some complex conditions, and when you don't choose the best database for your design, you will struggle. It will be a nightmare in the short future. It's just some days you can transfer your database from a NoSQL database just to a relation database, but it needs works. So talking about database, you need to choose the best index, and you need to think about consistency, a capturing, consistency, availability, partitioning. I love NoSQL databases because I don't care mostly in my design, in my teams, in my software, the business value that I'm providing about consistency. No, I don't care about consistency mostly. So I prefer availability and partitioning over consistency. So these three terms is important to think about. What do you want? And thinking about database, we think about data and how we can manage data. We're storing everything everywhere, and no data has a life cycle for a long time. That's depend on your business, your software. So we are not using a single item of data for 10 years. There is no value behind that. So we have hot data, which is behind your system, and you are needing to query them, you analyze them, to do something with them in real time. So this is the standard kind of storage. And we have some kind of data that you need to keep them available, but you don't like to use a huge performance storage, which is a bit complex to keep them, because you want to use them rarely. So in frequently access data, we set them in this kind of a storage. And finally, I like to say, go remove them when you don't need them. But based on juridic, the personal information regulation, we need to sometimes keep data aside for a long time, for 5 years in Europe, I think, I kind of this stuff. So we can archive them. We can compress them, archive them, and leave them aside for just the usage. So we are improving the consumption of storage now here by separating these layers. And finally, don't use data. Don't use data. Don't store data. We have two kinds of storage: permanent storage and temporary storage. A queue is a temporary storage. Now, you can use temporary storage. You can use a DL queue if you want to observe. Don't use the SQL databases or Oracle databases, or cluster databases, kind of AWS Aurora with a huge bunch of replication to just, do something simple. We talk about data. Now, we use brokers to make things happen in serverless, basically. So here, in this diagram, I have a simple API. I have an API, microservice, well-scoped and well-designed, and I have lots of consumers. They're fetching the data. They're calling me at the real time. They're fetching the data. Again, this pattern that I am talking about, that's based on your business needs, that's your customer needs. But the simplest thing is that the consumer needs quality. They don't need data. A corrupted data go to the garbage. They will struggle. Their business will be impacted, and we cannot control all these consumers. How we can inverse the dependency direction? Just using the brokers. Let's imagine that some data is in my database. I will run a serverless function, a fast function, and behind that I'm pushing just data into a broker, and I'm notifying in real time based on the evolution. So I guarantee the quality of my system, but behind that I will leave the consumer, relax. I will notify you. So here we are inversing the dependency directions. We are not controlling the business of consumer. We are guaranteeing the responsibility or responsibility. This is a shared responsibility. And we are lightening the communication. We are removing all the fetch data that has no result. A 200 without any data inside, 0 elements, it's not useful. And keeping forward with the precedent slide, this is the final slide that the final design that we have in the precedent slide. So here the problem is that we are moving everything to consumer. They need them. This transfer is optimized. So let's jump and say we will trigger you. We will process something. We will change our data or entities, database, any kind of data storage, and behind that we will push an event. So we will transferring essential information. We will notify the lightweight in a lightweight format. And also we need to keep the data and our systems near the consumers. So if you have in Asia consumers and in United States consumers don't use your service in France, it's out of question. And behind that, what's the problem here? That we are communicating, we are pushing the lightweight information, the metadata information, essential information to the consumer. We are notifying them to say them something happened in our system. Are you interested about that? So, between the three consumers, how many consumers will be interested to fetch that data? So I just, instead of pushing 400 kilobytes, I pushed just 1 kilobyte. And now, this is a single consumer that at a given time needs the data. So I make a microservice behind that to be able to fetch my data. This is a high-level schema. So you can break it down with your design internally. But let the consumer optimize or transfer by giving the consumer the choice to improve their business requirements. So if you can cache your data, it can be helpful in some scenarios. And we talk about events. So I see in the event-driven design, we are just pushing the data. The company name, the company location, the company commercial marketing commercial identifier. But are all this data are needed? For me, an event is not data. An event is a bunch of useful information for communication. So we need to keep it lightweight, as I said in the preceding slides. And here we are communicating in two different bonded contexts, to different softwares. And we need to identify the operation. What's happening in your system? I'm removing Omid. Okay, you have an event for Omid removed. So you need to identify what's happening in the business term to Omid. It's unsubscribed from our system. That's why I'm talking about. And creating this transfer is important. And tracing this communication, most of the time, I'm personally using the servers. I'm using the monitoring system. I'm using my local computer to just find a problem for 2 hours, 3 hours. This is lack of communication and trace management. We need to manage the communication and trace the communication in a huge distributed design. So let's add some context-specific information that can be useful between two bonded contexts in a business perspective. And let's go to compute. What's a compute? What is a function as service? What's a serverless function? A serverless function basically is an ephemeral container. So ephemeral container is initiated for you, is warm for you to invoke your code, and finally it's clean up. It's a shared container. That's why we call it ephemeral. The container is a cloud provider, kind of Azure or AWS, is persistent. It's running on the server, but just we are optimizing this sharing of data. They guarantee the security part to purge well or container, ephemeral container where we don't need them. But behind that, we need to optimize the initialization files, invocation files. The cleanup is guaranteed by the cloud providers or fast providers. So we are giving some containers, we are freezing them after the usage, and if you need again, we were towing the initialized container to do again. So what's happening with the first two requests? The cloud provider give you two containers, ephemeral containers, initialization, invocation. The third and fourth, we will reuse the same containers that are available. Imagine that you have another request and another one. We will give you extra containers. After that, if after the termination of this invocation, all this invocation, as soon as you have 4 requests, we will give you, we will use the already initialized container. So we are avoiding the initialization phase. What is initialization phase is preparing the environment. It's preparing the runtime. It's uploading your code, your package into the container. To make the environment ready to go forward. So we need to optimize any part of this. In the evocation phase, you can optimize your code. So configure well your serverless function in the term of memory or CPU. If your system is CPU needs some CPU or memory, or needs just time, Behind that, there is some runtimes that are huge. Come Java. Java initialization phase in the serverless for Java is so twice more than TypeScript, Node.js, or JavaScript, or Go, and Rust is the better, which is, I love Rust because it's sustainable naturally. Now it's optimized for consumption. So we need to keep the packages small, and the runtime preparation. We know that if we are using Java or C#, there's something happening extra because they need SDKs. There is runtimes. There is preparation of environment. So like Java, it's really C# is now better. I can compare. I can use the same thing that I did with Node.js with C# now. So think about that. And to optimize the business needs, some guys define the provision concurrency. What is provision concurrency? I said to my cloud provider, I need a minimum of 100 containers available at any given time. The containers are allocated at you. So you have 100 containers already initiated, and for you, it's not shared with other customers. So if you don't need this 100 concurrent container be available, don't use that. Don't do that. I never use provision concurrency. I never. If I struggle in terms of business value, the problem with customer, I will do that. But basically, I never do that. And finally, cleanup. During cleanup, if another request, we will reinitiate. Until now, we talked about physical part of containers, and let's say in the compute. When we talk about compute, the recommendation is if you want to be sustainable, make this asynchronous. So making something asynchronous, remove the dependencies, remove the problems inside your business from the outside. So what's happened here? Consumer called your API gateway, a function as a service, serverless function, and behind that you have a hot dependency, an API that is not performing well. How we can improve that? Just make that asynchronous if possible. Make that asynchronous if possible. Just API gateway directly to a queue, and behind that the queue will trigger your serverless function. And also we can remove that dependency, optimize that dependency. A dependency, what is interested in the dependency side is that you need some entities, some dependency information, data, some products. Is this product available? Your ordering system, for example. And this dependency can push the event, the changement in the product system, and you can project them and evaluate your local database. So here we are accepting to not be consistent. We are eventually consistent. If you can accept that, it's an event query transfer state pattern that it can be useful. In this kind, you don't care about queuing. You can go, based on your need in some design, we cannot make everything asynchronous. At this time, we can go over optimizing our dependencies. We have two kinds of dependencies, dynamic, static. So the static ones have a hardness of constant, and the dynamic one are out of your control, kind of APIs, cloud providers give you some services, your legacy systems in another partner system. And so use the Neoverse architecture. Neoverse is an optimized processor architecture that, for example, in AWS, it's called ARM64. So it's sure, and I don't remember the name in Azure. Now, I use that I don't remember. So service integration, VS function. Avoid coding for everything. So you can, for example, in this design, API gateway is interacting directly with the queue. I'm not coding to write in the queue. So thanks for being here. It was a pleasure.